Hi and welcome to Gaffey's Grinds. My name is Mr. Gaffey. I'm a science teacher and I'll be taking some topics in these videos from junior psychoscience. I'll be breaking them down, trying to help you understand them, explain them very simply as I can. Then we'll do some practice questions on those topics. Okay, so this is video 6 of our series on particles. So what substances are made of and how particles behave. I highly recommend that you watch these videos in order. So if you haven't watched 1 to 5 already, these videos are going to make a lot more sense if you watch those ones first. Some quick tips, as usual, the same things I always say, is eliminate any distractions that you might have. So your mobile phone, if you can, you should stick it in another room or turn it off somewhere where you're not gonna get tempted to pick it up and go and have a play on it. Any other tabs open on your computer, you should close them now because those are a big source of distraction if any notifications come in, etc. The last and most important thing I always say is I'm going to give you some tasks and some questions to do in these videos. It's really important that you do those tasks and pause the video and do them and give them your full effort when I ask you to. Otherwise, really watching these videos is going to be a waste of time. So you have to put pen to paper, have a go doing the questions. Okay, this video is going to be on dissolving. Okay, so it's going to be on what happens when things dissolve. So I want you to imagine that we have some water in a container. Okay, so we have some water in a container like this. Okay, so it's filled up to here with water, H2O. Okay, and to that we've got a sample of salt. So we've got this little pile of salt. This is a substance made of NaCl. Okay. Now, when we add the salt to water, we make a mixture. And the salt, well, it looks like it dissolves. Okay. So it looks like it dissolves. I'm going to rub those out actually because we can't actually see particles. Okay. Now, what's actually happening here is, well, we can explain this using the idea of particles. So if we scroll down to this diagram, in this diagram here, these particles here represent a solid. We know that because we have a regular arrangement of these yellow particles. They are in rows of 3 and they are very close together. They are touching, they are regularly arranged. So which of the substances above is represented using the yellow particles? So on 3, I want you to speak your answer out now. Is it the water or the salt? 1, 2, 3. Okay, if you said the salt, then you are correct and well done. This is the salt. So these blue particles here, these represent a liquid. They are close together, but they are not regularly arranged. They are not fully in these straight rows and all touching. They have a slight bit more space between them. So these are liquid particles and they represent, from above here, they represent the water. Okay, now what happens when we mix the salt and the water together is, well, we get the result over here. This is what we call salty water. Now the process, the arrow here, what actually happens? What does this arrow show? Well, this shows us a process that we call dissolving. And if we go back up to our previous diagram, we can also write dissolving here. So we say that the salt dissolves in the water. The salt is dissolving in the water. Now, does it disappear? Well, from our particle diagram here, we can see no, particles do not disappear. So what actually happens then? Well, hopefully you can see that they've gone from all being attached close together and regularly arranged to now they are spread apart and they are basically detached from each other and they are spread amongst the water particles. So they break away from each other and they move into the water. That's what dissolving is. Now, for that to happen, well, we need to know what is holding the particles together in the salt. So you should know the answer from previous videos. What holds together particles in a solid salt? So on 3, speak your answer. 1, 2, 3. You should have said forces of attraction. So forces of attraction between the solid particles of the salt hold them together in that structure. Now, obviously, over here, the particles are separate. So mixing them with water, making them dissolve, means that we can break forces. Another way of saying break is overcome. Break or overcome the forces of attraction. This lets them spread out, mix with the water. So breaks the forces of attraction. That's what happens when we mix a substance with water and it dissolves. We break the forces of attraction. Now, we have some words to describe the different parts of this. This is now a mixture. Now, why is it a mixture? Well, here we have a pure substance. Pure substance means made of only one type of particle. Salt is another pure substance because it's made of only one type of particle. As we can see here, yellow dots. There's nothing else in there. Whereas the salty water, we now have a substance which is made of two types of particles, but they haven't made a new substance. They haven't joined together to make blue and yellow particles that are attached to each other. We can clearly see here, there's a space between the blue and the yellow particle here. This is not something that's like a new substance. We call this a mixture. So this is a mixture of salt and water, okay? So more on mixtures later. So we're not gonna focus too much on that right now. So we have our water and our salt to make salty water. Okay, now we have a word to describe each of these things. The pure salt, or the substance that is the solid in this case, is we say that this is the substance that dissolves in the solvent. Or dissolves. This is the substance that dissolves. Sorry, I won't use that other word yet. Now, the substance that dissolves is what we call the solute. S-L-U-T-E. So it's the solute. It's a substance that dissolves. It's the solute. Okay, so we call it the solute. So the salt, in this case, is the solute. The water, in this case, is the substance that dissolves the solute. Substance that dissolves the solute. We call the substance that dissolves the solute, we call it the solvent. Substance that dissolves the solute, so we call it a solvent. The water in this case is called a solvent. When we mix together the solute plus the solvent, we make a mixture. Solute plus solvent. The mixture in this case is called a solution. We call it a solution. So the solution in this case is the salty water. Salty water is the solution. A solution is a mixture of a solvent and a solute. Okay, so we've made a solution. Back up here. Let's see, can we name which one is the solute, which one is the solvent? Okay, so the salt, what is that going to be? Is it the solute, the solvent, or the solution? On 3, 1, 2, 3. The salt is the solute. Well done if you said that. The water, what is it going to be? Is it going to be the solute, the solvent, or the solution? The water is going to be the solvent because it dissolves, the solute. So underneath then, what have we made? What is the mixture afterwards? I'm showing that the salt is spread around here. We can't see it, but it is there. So the particles are in there, we just can't see them. Okay, so what do we call this mixture? Okay, I hope that you said, sorry, this is the salty water. Hope that you said it's the solution. Solution, because it's the mixture of the solute, the solvent. Okay, let's take a look at another example now. Okay, let's take a look at another example. Imagine you want to make a cup of coffee. So you take your cup, it's got a handle. Okay, and what do you need to make a cup of coffee? You need some water, H2O. You need your coffee granules, coffee granules. Okay. I'm going to take my coffee granules and I'm going to put them into the water. Okay, I want you to tell me what is the name of this process. On 3, 1, 2, 3, speak out your answer now. Okay, we call it dissolving. So if you said dissolving, well done. We say that the coffee dissolves in the water. I want to know which of these substances is the solvent. Which one is the solvent? Name your answer on 3, 1, 2, 3. Hope that you said water. Water is the solvent. Why is it the solvent? Because it's the substance that dissolves the solute. The solvent is the water. We then have coffee granules. What is the name we give to this substance? I hope that you said it's the solute. Why is it the solute? Well, it's the substance that dissolves. And finally, we have the mixture, which is the cup of coffee. Cup of coffee. What do we call the cup of coffee in this example? On 3, 1, 2, 3. Okay, I hope that you said we call it the solution. It's the solution because it's a mixture of the solute and the solvent. Well done. If you got that correct, you now have 2 examples of solutions. There are lots of other examples of solutions. Anything which dissolves and mixes together and basically looks like it disappears will be a solution. Now, we've looked at 2 cases where water is the solvent, but it might not always be water. There are some other solvents, which we, again, will see later on. It's question time. Let's do these questions to check your understanding. So here, at the bottom here, are some key words that you have to fill in. So what I want you to do is I want you to pause the video and I want you to complete the key words. Okay, so pause the video and in your copies, complete the sentences in full and add in the key words. The answers are going to follow. Pause the video now. Okay, so you should only be watching the video if you have paused them and tried to write them sentences and fill in the key words. These are the answers. Check them. And if you need to stop and fix them, do that now. Okay. Good. So at this stage, what we might do is we might take down the meanings of some of the key words. So the first one we might take down is solute. What is the solute? The solute is the substance which dissolves. Okay, so the substance which dissolves in the solvent. Substance which dissolves in the solvent. That's the solute. Okay, what is the solvent then? Just going to reduce the size of the pen here. So that's a bit too thick for me. Okay, so solvent. So 1, 3. Describe what the solvent is. Okay, it's the substance that dissolves the solute. Now, the solvent is usually a liquid. Usually a liquid. The solute is usually a solid, but not always. Solutes can be gases. For example, oxygen is a gas. It's a colorless gas. It can dissolve in water. This is really important because it's the reason why fish can live underwater. So they can breathe the oxygen, which is dissolved into the water through their gills. So they don't have lungs like humans do. They breathe through gills, but there has to be oxygen dissolved in the water for this to happen. Sometimes when water gets polluted, the oxygen gets used up. So all the dissolved oxygen gets used up, and then the fish have no oxygen to breathe. So it's really important that gases as well as solids can dissolve in liquids, in solvents. Okay, so sometimes the solute will be a gas, but most solutions that we're talking about, the solute will be a solid. Next one, what is a solution? On 3, what is a solution? Speak your answer. Okay, you should have said it's the mixture of the solute and solvent after dissolving. Okay, it's the solute and the solvent after dissolving. So dissolving is the process that makes a solution. Dissolving. So what is dissolving? What happens in dissolving? Explain your answer to the screen on 3. 1, 2, 3. So dissolving is when the forces of attraction in a solute break up and the particles mix with the solvent. That is what dissolving is. So the forces of attraction in the solute break up, and the particles of the solute can then mix with the solvent. We've got 4 keywords, really important words there that we understand, that we know, and that we can explain. Okay, so those words are really important things that we need to learn and be able to use and describe. Okay, so if we were summarizing, to summarize solution, made of, what is it made of? Okay, so on 3, I want you to stop, pause the video, and then to write in what are the 2 things the solution is made of. Okay, so you should only be watching the video if you pause and try to complete this little summary diagram. So the solution is made of the solute plus the solvent. Solute plus the solvent. Okay, and the process that lets them mix together is called what? On 3, so write down the answer just underneath this arrow here. So in here, what is this process called? On 3, 1, 2, 3. Okay, so pause the video. Okay, so you should have written dissolving. Sorry, spell it right. Dissolving. This process is called dissolving. And the solute dissolves in the solvent and makes a solution. Okay, got some more practice questions for you to do. All right, so a little bit more challenging. So we've got questions 1 to 3. So I want you to pause the video now and try these questions. Okay, so you should only be watching the video now if you have paused the video and tried your best to do those questions. It's really, really important that you give a good go at these and you try and get high quality answers, writing full sentences, etc. So again, if you didn't try very hard or you don't think your answers are up to scratch, pause it and make sure you give them your full effort. Do that now. Okay, so you should be watching the video if you have completed the questions and you're happy with your answers. I'm going to show you the answers now. You're going to pause the video and make any corrections that you need to make to your answers. So down as far as number 3, where I am going to have to pause the video and draw in the answers. Okay, so just pause the video and check your answers to questions 1 and 2. Okay, so you should have checked your answers to 1 and 2. You should have either corrected them with a tick like this, or you should have fixed them and changed. If your answer is not the same as that, you need to make sure you change it. Okay. So let's just go back up and check what question 3, so 3A and 3B. So 3A says, has a student adds sand to the water and mixes it, she can still see the sand at the end. Has the sand dissolved? No, the sand has not dissolved. Okay, because if it doesn't look like it's disappeared, then it hasn't actually done anything. It hasn't dissolved. The particles have not broken up and mixed with the water. Explain your answer using the word particles and forces. So this will be a good answer. The solvent is not able to break the attractive forces between the particles of the sand, so it doesn't dissolve. C and D then need me to draw. Sand has a melting point of 1650 degrees. Draw a particle diagram of sand at 1500 degrees. Okay, so if you think about, you have your number line that we did the last day. And on our number line, we have our melting point. And we have our boiling point. Melting and boiling. Now, we don't know the boiling point right now. We know that the melting point is 1650 degrees, 1650 degrees. And it's asking us, draw a particle diagram of sand at 1500 degrees. Well, let's find out. Obviously, I've forgotten this. So solid, liquid, and gas. So we have to find 1500. Well, 1500 is less than 1650. That means it's going to be down here somewhere. This is 1500. So if it's 1500, then that means it's in the solid state. It hasn't melted yet. It won't melt till you heat it up to 1650. So I have to draw a particle diagram for a solid. That's what I had to do in this question. So this is how we do it. We've got particles in neat rows, regular arrangement, all touching each other, solid. At least 9 particles. Okay, D, draw a particle diagram of sand at 2000 degrees Celsius. Okay, well, we're not sure the boiling point, but I think it's going to be a bit higher than 2000. So when it gets to 2000, I think that's going to be around here somewhere. It's going to be in its liquid state. So for D, you have to draw a particle diagram of a liquid. It's the same particles, they haven't changed, they're just arranged differently. This is a liquid. This is the sand when it melts and turns into a liquid. Last one then. Explain why sand cannot be compressed. Sand is a solid and cannot be compressed because the particles are too close together. That means there's no empty space to be compressed. So like some of those questions were revision of previous topics. It's really important that we're always thinking back and we're always revising and we're always making links between what we already know and what we're learning new today. All right, that's the end of this video on dissolving. Okay, so I hope you found it useful. I hope you were able to do the questions without too much help. If there was something you didn't understand, as always, pause the video and go back and listen to the explanation again. Okay, right, so that'll do for today. I'll see you in the next one.